Hello, my name is Keshwani. That's Keshwani. I have been solving math problems for GMAT out of this book here, the GMAT Review, the official guide. The problem that I'm about to solve, this is 11th edition. The problem that I'm about to solve is the one that you will find in this book on page number 186, problem solving, number 249. Page 186, 289. If you happen to have the newer edition, the 12th edition, don't bother looking for this particular problem in this book. It does not exist. They have taken it out. They have taken it out, and hence the notation that it is not in 12th edition. Let me put it in a red pen if I can find it. It is not in 12th edition. Well, let's get going then. It's important that you have the question in front of you so that you can read the thing with me. And if you do not own the book, purchase one immediately. You need it. One needs it if one is to sit for the GMAT exam. This is the best resource that you can find. Don't waste your money buying all the other mumbo jumbo that's on the market. This is the book you want to practice out of. Let's take a look. If n is a positive integer less than 200, okay, there are three conditions we have to meet. First is that n, we are told, has to be positive. I'm told that n has to be an integer, and then finally we are told that it has to be less than 200. Let's rewrite this thing properly. N has to be less than 200. I'm not sure if it's an improvement or not. Anyway. And then we are told that 14 times n over 60, this quantity, 14 times n over 60, we are told it's also an integer. The question simply is, how many prime factors are there of n? N has how many prime factors? The very first thing I'm going to do is I'm going to simplify this bloody thing. I don't like it the way it's sitting. Let's simplify it. This 14 becomes 7 and this 60 becomes 30, which is what I have here. 7n over 30 has to be an integer. Let's get going then. Let's solve the problem. Since the very first thing we should realize here is that since this 7 and 30 have no factors in common, 7 and 30 have nothing in common. There is no number that will go evenly into 30 and 7. 7 and 30 have nothing in common. Therefore, in order for this quantity and this quantity to be an integer, the only way this quantity can be an integer is when this quantity here, n, is some multiple of 30, which is the notation here. So let's start again. Since 7 and 30 have no factors in common, that implies that in order for this quantity to be an integer, n would have to be, this implication is not needed, n would have to be some multiple of 30. For example, n can be 30, 60, 90, etc., etc. So let's get going. Let's try out different numbers here. Let's start with 30. What if n equals 30? All I have to do is find prime factors of 30 and then find the prime factors of 60 and 90 and 120 and so on and so forth. Figure out how many prime factors are there if n were 30 or 60 or 90 or 120 or whatever. Well, let's see. 30 can be broken up into 2 and 15, and 15 can be broken up into 2 and 5, 3 and 5, and therefore it seems to me that the 30 has 3 prime factors, namely 2, 3 and 5. What if n were 60? Well, let's see. If n were 60, we will break up into 2 and 30, and then of course we are back to where we started. But you see, one would not count these two n twice. We're not going to double count them. This is one factor. 2 is a prime factor of 60. 3 is a prime factor of 60. and 5 is a prime factor of 60. What does prime factor mean? I should have explained this thing in the beginning, I forgot. In order to find the prime factors, one usually finds all the factors of 60, and then once you have found all the factors of 60, you sit there and ask yourself which one of these numbers are prime numbers, and those are called prime factors. 60 has 3 prime factors, just like 30. 60 has 2, 3 and 5. Of course 60 will also go into 15, and 60 will also go into 30, and it will also go into some other numbers. 60 will go evenly into 60, but those are not prime numbers, those are not prime factors. Those are factors of 60, but they're not prime factors of 60, because 30 and 15 and 60 are not prime numbers. What if n were 90? Well, 3 times 30, and we're back to where we started. 3 times 30, we already counted 3, and then we have 30. 30 again would have 2 times 15, and then 3 times 5. Again, these two 3's will not be counted twice. We're only going to count it once. So 3 is a prime factor of 30, and so is 2, and so is 5. Just like before, there are 3 prime factors. What if n were 120? 120, well, it's just 4 times 30, and we're back to where we started, because 4 will be 2 and 2, but we already counted 2. So as you can see, it also has only 3 prime factors, 2, 3 and 5. What if it were 150? Well, that's just 5 times 30, and again 5 has already been counted, so it has only 3 prime factors. 150 has only 3 prime factors. What if it were 180? Well, again, there's 6 times 30, and 6 has the prime factors of 2 and 3. Well, both 2 and 3 has already been counted in the 30, so there are only 3 prime factors of 180. What if n were 210? Then it will break it into 7 and 30. And then of course 2 and 15 and 3 and 5. Oh boy, now the answer has changed. Now we have 4 prime factors. 210 has 4 prime factors, namely 2, 3, 5 and 7. How can the answer change? We've been saying all along that n has only 3 prime factors. How can the answer change? I want you to pause this video right now as you're watching it. Just pause it, stop it, go back to the problem, solve it, take a look at it, and tell me when you come back, when you figure it out, resume the videos and see if you can figure out what's going on with 210. Why? How can the answer all of a sudden change? We've been finding 3 prime factors. In the meantime, I'm going to go in the back and see how much time I've spent so far. Alright guys, I hope you figured out what's going on. So how can the answer change? We have been finding 3 prime factors. When we're looking at 210, there are 4 prime factors. Answer cannot change like that. It's not arbitrary. What is going on is the fact that we were told from the very beginning that this n has to be less than 200. It cannot. That rules out 210. It cannot be 210. The only possibilities are 30, 60, 90, 120, 150 and 180. That's it. Et voila. That's it. And we also don't have to worry about the negative factors, because we are told that it's positive. Every single thing is there for a reason. By putting this constraint on n, there are only 6 different scenarios, and no matter which of these 6, no matter n happens to take, no matter what value n happens to assume, whether n is 30 or 60 or 90 or 120 or 150 or 180, there are only 3 prime factors that n can have: 2, 3 and 5, and that's all. Well, I hope you found this helpful. If you wish to get hold of me for personal private tutoring, I am located in Connecticut. I do tutoring, most of my work I do it in Connecticut and in Manhattan area. But of course, as I've said in all my previous videos, it does not stop me from going anywhere on the planet as long as you and I can come to an agreement. I've been to several different places. So if you're interested in personal private tutoring by me, please go to my website at www.prep, gmat.com. Also, if you're interested in purchasing solution manuals to all the problems, both the data sufficiency and the problem solving, again, go to my website and send me an email. And I'll see you in the data sufficiency problem when I start them. Notice I didn't say if I start them. When I start them, I think I will. In a few days. We'll see. Alright? Again, thank you very much.